Okay, so I will start with the major forms of artificial lift. So these are, sorry, I'm putting on FTP. I could not put it on WhatsApp and also on other forms. So you have to live with that. So if there is any complication or any problem, actually you can deal it later. But let's see, the presentation now. So first of all, actually, what's the idea behind inflow and outflow performance? If your PO is less than PWF, the well will flow naturally. This is a common concept. Only 6% of the wells flow by number, and if PO is greater than PWF, well will require artificial lift. 94% of the wells worldwide are on artificial lift now. Okay, this is well inflow and this is well outflow altogether. So this is the inflow performance relationship. Straight line PI, PWF is PR minus PWI, and Vogel correlation is Q by Q max minus is 1 minus 0.02 PWPR minus 0.8 PWPR square. This is the Bible to our artificial lift system. This whole system is designed and structured based on this equation. I don't want to go in detail. Obviously, it's available in literature. You can always check back on Google and also on the Wikipedia. So this is a straight line versus Vogel correlation. This goes all the way, ideally, but somehow actually because the gases actually deviates from the straight line and the actual performance goes on the red. And from here onwards, actually, this is above bubble point pressure. It goes straight to the surface to the wellhead. And here, PO is pH1, PFR, PWH, where pH is hydrostatic pressure, PR is pressure drop due to friction losses, PWH is wellhead pressure. Several correlations have been developed to better model fixed flow outstanding different factors such as flow regime, water cut, viscosity, well inclination, roughness, and hold up. Pressure to head conversion is convert pressure that is actually head and feet is pressure in PSA, specific gravity 0.433 PSA per foot. So the concept of artificial lift is needed when reservoir pressure do not sustain acceptable flow rates or there is no fluid flow at the well at all. So lift process transfer energy downhole or decreases fluid industry in the wellbore to reduce hydrostatic pressure to formations. So artificial lift methods overview. There are different artificial methods, which is beam pump, which is a very old concept in service since the 18th century, hydrolift, drill lift, gas lift, and ESPs. And now I'll be talking mostly about the outline, how the artificial lift is important actually in the industry. Artificial makes 94% of the wealth. And artificial lift, this is the data back in 2004. And sorry, I couldn't update it actually because anyway, but it gives you a picture. So rod pumps are actually 79% worldwide, and there are so many wells. Electric submersible pumps 12%, PCB is 4%, gas lift 3%, and hydraulic pump 1%, others 2%, and this gives you the total numbers. And talking about the revenue, rod pump revenue is 717 million, electric submersible pump is 1725 million, PCB is 369 million, gas lift is 130 million, hydraulic pumping is 30, and others is 329. Now, worldwide, actually, the highest numbers are available installed in Russia. You can see that is 121,000 back in 2004. Now they're exceeding 200,000. Yeah, China is also catching up. Indonesia also catching up. Australia is catching up. Argentina is also on the top of the list. Brazil, Venezuela, Peru, US, 541,000 wells. Canada, 48,200 wells. Now Canada is crossing almost 100,000. Yeah. These are artificial lift application ranges. You can see this. Well, first of all, this is rod pump. You can see this rod pump is yellow. Yellow line covers up till here. PC pump covers up to this range. And hydraulic lift covers, this range only. And submersible pump covers this one. Gas lift covers the most. Artificial lift system efficiency includes the most efficient system is PCP. Then is the hydraulic piston. Then is beam pump. Then is ESP, somewhere in the middle, about 50 to 60%. Hydraulic jet pump is this one at the tail. Gas lift is also the tail, and gas lift intermediate is LD bottom. The artificial selection, making artificial decision, is primarily a process of choosing the lift method most applicable to expected surface reservoir fluid and operational conditions. So these are artificial method applicability, not one size fits all. For scale, the most suitable system is hydraulic. For sand, most suitable is gas lift. For paraffin, most suitable is hydraulic. For corrosion, most suitable is rod pump. For HGR, most suitable is gas lift. For rate, high suitable is gas lift and ESPs. For depth, is hydraulic lift is very good. ESP is good. Gas lift is good too. Flexibility, all of them, they are very good except PCP somewhere. And temperature-wise, most of them, rod pump is the very good, and fair and good ESPs. Nowadays, there's some development in the ESPs. We can run up till 220 degrees centigrade. Some of steam injected wells, we are running ESPs now, but they are very specialized ESPs. This is your artificial selection criteria. I don't want to go in detail. This is a miniature kind of approach. You can ask me to send you the Excel sheet, and you can select it actually. Which one is suitable. The green one is a suitable one, and the red one is not suitable. So sorry, I could not enlarge the screen, but it tells you which way and which conditions most suitable lift system. This is always have been a question to us, because out of the 4 to 5, which one to select? Yeah. But in my ongoing slide, you'll find actually which one is commonly accepted and which one has got more applications in industry by now at this stage. Reciprocating displacement rod pumps now begin dealing with one by one. Transfers of mechanical energy from surface to rod, string to downhole pump. Rod pump combine a cylinder barrel and a piston plunger with valves to transfer well fluids to the tubing and lift the fluid to the surface. Rod pumps advantages are most widely used in artificial method, best understood field personnel, usually the cheapest mode, low intervention cost, remote locations can be easily installed, readily accommodates volume changes, reliable diagnostic tools, and can often pump below perforation. Yeah. Disadvantages: restricted flow and depth. Yeah, mute करें जरा please. ये कौन सा आवाजें आ रही है background से?
Please mute everybody.
Okay, restricted flow and depth. Disadvantage: susceptible to free gas, a frequent maintenance, and deviated well bore are difficult rod tubing wears, reduced tubing bore, susceptible to corrosion, potential wellhead leaks. Now, progressive cavity pump displacement pumps is the next one. The progressive cavity pumps are based on rotary fluid displacement. This spiral system consists of a rotor, and a stationary stator here. This is outside the stator, this one. The mechanical energy transfers via rotation sucker rod. Sucker rod is installed at the tail of the rotor, and transfer via rotation sucker rod pump are electrically bottom drive. So stator and rotor and connected with the rod, and on top is is the prime movers. So PC pump applications is a heavy and viscous oils, production of solid laden fluids, medium to sweet crude, coal bed methane gas well watering, urban areas, agricultural areas. You can see the size, PCP versus rod pump. The progressive cavity pumps are advantages: simple two-piece design, excellent for viscous fluid, resistant to abrasive and solids, non-pulsating does and does gas lock on emulsifier fluid, oil gravity 5 to 40 degrees API, fair flexible application, and efficient power range. Disadvantages: sorry, just don't get mixed up with the sign. This is my Instag, was a kind of a presentation I did in Calgary in last September. Yeah, so I put up their logo on there. So sensitive to do overpressure, sensitive to pump out, restricted flow rate, less than 5,000 barrels, restricted setting depth, 6,500 feet, limited operating temperature, 250 degrees Fahrenheit, not compatible with the same chemicals, HPS, high twist, and APA gravity. Now, coming up, gas lift uses additional high temperature pressure gas to supplement formation gas, produces fluids are lifted by reducing fluid density in well bore to lighten the hydrostatic column, back pressure, load, and formation. Gas lift as an artificial lift is application decrease fluid of average density, thus the hydrostatic load on formation is reduced so that the available reservoir energy can cause inflow, and commercial hydrocarbon volumes can be boosted or displaced to the surface. By injecting relatively high pressure gas from the surface to the determined depth and well bore, the average specific gravity of the fluid is decreased. So this is your schematic. You can see that, these are the mantle, the tubing, and this is your injected fluid, and this produced fluid that goes through all the way to gas separator and to the stock tank. Gas fluid advantage is fairly low operating cost. Flexibility can change rates by adjusting injection pressure, and pressure also easy to change gas lift valves without pulling out tubing, and harsh requirements. High volume lift method, 35,000 barrels per day, typical, very good for sand and deviated wells. Must have a source of gas. If gas corrosive, it will require treatment. Possible installation costs is top sides modification to this platforms, compressor installation and maintenance, limited by available reservoir pressure. Hydraulic lift pumping system is transfers energy from downhole, pressurizing special fluid, power fluid. Usually water or light refined oil are pumped through well tubing or ALS to a surface pump, which transfers the potential energy to produce fluids. Common pumps consist of jet, venturi, and or with nozzle. Reciprocating pistons are less widely used rotating turbines. Advantages of jet pump: no moving parts, can tolerate solids and deviated well bore. No rig required to replace pumps. Simple completion security. Chemicals can be injected with power fluid. No rig required to change sizes and tandem. Disadvantages: low system mechanical efficiency, 30%. High fuel energy running cost. High surface maintenance cost. Industry not familiar with the system due to past monopoly and supply and poor market and product knowledge. Hydraulic piston pumps are offered as an alternative to jet pumps. Higher efficiency up to 95%. Recipe: this is the most efficient system in the industry, but very very scarcely used because of its application. Reciprocating piston to lift product to surface. Hydraulically retrievable. Similar flexibility in design application. So ideal hydraulic pumping system is this size. You can see this. Yeah, this is a surface pumping system now. And these are multi-well installation devices, done here. And this is a portable unit. You can see this. Principles of operation: jet pump can be used as an alternative to piston pumps. They can fit interchangeably into bottom assemblies. Short bottom assembly can be used. Jet pumps assemble can be shorter and higher flow, referred to as the BAS 1852. First patents for oil sand were used in 1930. Jet pump overview: pumping action achieved with energy transfer. Higher pressure fluid passes through the nozzle. Potential energy pressure is converted to kinetic energy. Well fluid intermix and exit throat. Momentum entrains well fluid. Mixture passes through expanding areas, diffuses, slows down the liquid. Pressure of maximum must be sufficient to reach the surface. This is the graphical representation of the pressure head and your velocity head. You see your pressure head, and this one is your velocity head. Yeah. So nozzle and throat are so very handy and can be easily managed. So jet pump overview continued. No moving parts. Flow percentage can be exotic. Reservoir needs relatively strong drive. Has to be sufficient tubular space and well. Offers ruggedness, reliability, and volumes. PF pressure to 2000 to 4000 psi, 5000 maximum. Maximum well depth is 3,200 feet, 12,000 feet. Higher lifts. Production capacity is 50 to 10,000 barrels per day. Abrasion resistant. Total length of jet pump is 1.5 feet only. Gas can lead to reduced return flow gradient, less horsepower. Performance nozzle throat. I don't want to go in detail, but you're going to see, just have a look at the slide. Area of ratio, also don't want to go in detail, and anti-crisis examples. These are detailed equipment. Equipment selection: balancing the following: jet pump components. Nozzle too small will only circulate power fluid. Power fluid pressure could be too high for required lift if the throat area is too small. Cavitation happens. And power fluid supplied is the goal is minimum high pressure and maximum production. Now friction condition goal: keep losses to minimum for application. Jet pump application range. Yeah, I don't want to go in detail. This is a very explicit actually by itself. You can see this screen itself actually in the later range. So a typical hydraulic system, you can see this setup is a wider range and it can install in various fields. Open power fluid system is power fluid is produced, casing for installation, simple design, most economical design, ideal for chemical treatment, allows circulation of idle fluid. Closed fluid power system minimizes power fluid treatment, excellent abrasive corrosive, excellent offshore, and higher initial expense. Piston pump is the next one, same reciprocating action as a rod pump, ideal for low rates, low intake pressure, higher efficiency, maximum drawdown. Standard wellhead and downhole pump completion is a complicated well in completion is also it's very scarcely used in the industry in some typical areas for special application. Now comes the ESP, electric submersible pump. Electrical submersible pumps system is the multiple pump stages mounted in a series within a housing, mated closed into a submersible electrical motor, end-to-end tubing, and connected to surface control the electric power by an armor protected cable. You can see this. This is your motor, and this is your protector, and this is your intake, and this one your pump of this is your electric supply. But I'll talk in detail in all the system. Electrical submersible pumps is transfer electrical energy from the surface to a downhole motor that converts into mechanical force. The rotational movement turns the pump impellers and lifts the well fluid to surface. The ESP was induced as a means of artificial radar in late 1920s. There are a wide variety of pump sizes, capacities, motor horsepower, and voltage ranges of different application. ESP motor is a three-phase squirrel cage, two-pole induction design. It is the heart of the system since it provides the torque required to downhole the pump. This is the motor, actually. Schematic, this is the, you can see the section, cross section, and here it's installed in this way. Yeah. Motor components, the stator is composed of the housing material for a desired diameter. This one stator, yeah. And the housing material forms the cover of the motor and is threaded bottom to end and house basic components. These are stator laminations, 540 series, 562 series. And these are motor components. You can see this. The rotor is made up of rotor lamination. They are smaller in diameter than the stator lamination. And these create the iron core inside each slot. Copper bars with supporting copper and ratings. Rotor laminations with the copper bars. You can see this. Stator and rotor lamination, they are different sizes. And ESP motor selection is available in a number of different sizes, voltages, and horsepower ranges, depending on the size. Each application has got different motor size. And ESP protector is the one which is installed on the top of the motor. You can see this is one motor and it's not a protector. It stops the fluid. It protects, the protector is located directly above the motor and it stops the well fluid or any fluid entering into the motor. Yeah. ESP functions of the protector is the one installed on top of the motor, couples the torque developed in the motor to pump via the protector shaft, prevents entry of well fluid in the motor, provides pressure equalization, houses the bearing to carry the thrust developed by the pumps, and keeps it off the motor, provides a reservoir for the thermal expansion of the normal fluid. ESP gas separator is installed on top of the protector. In some applications, you can say this is motor, this is your protector, and this is your gas separator, the intake. If in some application, there may be gas produced along with the oil or water liquids. If gas is present, then gas separator can be installed and becomes the pump's intake to assist the eliminating some of the gas that might be produced through the pump. ESP pump is installed on the top. The multi-stage centrifugal pump consists of numerous impellers and diffusers. Application depends to provide the lift pressure required. The pump has a change head that can screw into the tubing. This is your cross-section of the ESP pump. The centrifugal pump is a machine that moves fluid by spinning it with a rotating impeller. And inside a stationary diffuser, this is your impeller and this is your diffuser that has a central inlet and a tangential outlet. The pressure head develops against the inside of the diffuser And the curved wall forces fluid to move into circular path towards and into the impeller and diffuser above. One impeller and diffuser makes one stage. One impeller and diffuser makes one stage. This is maximum head capacity, 4.5 inches casing. You can see 15,000 feet. It can lift up to, and 10,000 feet of lift up to casing, 5.5 inch casing, and 7 inches casing goes the maximum, application. But it can go up to 10,000 barrels, yeah. And the depth. These are your pump performance curves. ESP operated 3,500 RPM and 60 cycle power supply and 29 RPM 50 cycle power supply. This is a standard ESP curve, yeah. And this is your applicable, permissible range. And here, if it runs, this is running down thrust, and if it runs here, this is running up thrust. This is the most dangerous to the ESP run life and the operating conditions. So we try to run all the time to keep the ESP system within this range. This is our, by monitoring, by sizing, by designing, and by operation. The power cable is the one, motor lead extend and motor. Electric power is transferred to motor through an electrical cable bent to the tubing. You see this one? Bent to the tubing all the way and enters into the motor here through a pot head. Yeah. So ESP power cable consists of 3 copper conductor wires standing from the top of the motor. Flat cable lead to the wellhead. Flat cable installed actually across the motor, across the pump. On top of it installed a round cable. So bottom hole temperature and fluid properties are critical for the selection of cable. The electrical cable has been refined over 3 years to be used especially for the oil well application. ESP power cable components. First of all is the conductor, then is the insulation material, then is a barrier jacket, then is a chemical and gas, concentration and the protector, and then is your mechanical armor. Yeah. These are your surface equipment, your transformers, VSDs, junction boxes, and the wellhead. Surface equipment, the wellhead is the device that is installed at the surface of the well casing. This is your wellhead, special wellhead installed for the ESPs. And it allows the tubing, at the same time it allows the mandrel, which allows the power cable and the current through the wellhead by, containing the well fluid and the pressure within the system. The purpose to support the tubing string, cable and ESP and contain high pressure conditions often present within the casing. Special wellheads are required to allow for cable and connector passage. ESP surface equipment is the electrical transformers, step down transformer, step up transformer. Transformers can be either single or 3-phase. This is your complete schematic. Here, this is your perforation. This is your motor, pot head, protector, pump intake, pump, and the cable, and the other tubing, and the wellhead. And this is your production wellhead, and allows here the power goes through from the transformers to the motor controller junction box, which junction box is the one actually which allows the gases to exit from the cable, or there's anything stopping the entry to the motor controller. And here it goes to production. ESP junction box provides a connection point for the surface cable from the motor controller panel to VSD, allows for any gas to vent that may have migrated to the power cable, provides easy surface accessible test point. ESP switchboard is the one is used to energize motor, contains the motor controller, which controls running the parameters and provides protection to the system. The controller also provides the capability to monitor the production system with the use of recording, and there are lots of things that are installed in the motor controller. This is VSD, is a VSD, the pump is designed for a specific rate and condition, but in case you wanted to change the pump conditions and operating range, then you have to have a different condition, which is a different frequency. Now, this is an easy way going for installing a different pump each and every time. One pump can be rated for supplied with a varied frequency. So VSD is the one actually which supplies the varied frequency. The variable speed controller allows flexibility of the downhole system. For flow control capabilities, it provides a constant ratio between voltage and frequency. The ESP advantages can achieve high production rates. When VSD operated can offer flexibility to accommodate changing conditions. can be used at low bottom hole pressure, can operate reliably at deviated and offshore wells, can sometimes operate below perforation, can operate under conditions such as higher bottom hole temperature with the use of alternative materials, can utilize the test well by using a VST. Disadvantage is the pulling unit is required, high temperature effect, cable and condition installation, high dogleg facilities are a problem always, available electrical power required horsepower, a use of switchboard is limits the flexibility, high gas constant limits capabilities, high solid may cause rapid. Because nowadays there are some ESPs available now with a special condition, which can overcome all these conditions which I have laid down here. There are some ESPs available nowadays. Even then, we can run 10 barrels per day, and to that extent. So ESP summary: electric submersible pumps, it can operate in deviated wells, most efficient. Tubing must be pulled. Depth and gas oil ratio is capacity is operating efficiency is the is the challenges. Large volume of free gas can keep gas to the pump. This ends my presentation. But now I will show you some of my I'll show you actually the virtual operation of the different systems. This is the gas lift. You can see how does it operate. With the courtesy of Weatherford. These are video clips actually. It tells you how the system operates.
Excuse me, Walsam, I think we're unable to watch the video.
Say it again.
We are unable to see the video. You could please just share the video.
Just a minute.
Yeah, please. Thank you.
Just a minute. You are not able to watch the video, right?
There's no video here.
Let me go back. Is it can you see this screen?
Yeah, the screen is saying end.
Yeah, the last slide we can see, I mean, the end slide. And
okay. Now let me share the screen with you here. I don't know how to. That's right. Yes.
Walsam, you can quit your presentation and you can.
Now I'm going to quit my presentation. Now I am going to go back, share the screen.
Also, your presentation is not finished yet. I mean, it's still showing end. That means it's not.
I'll have to come out of this presentation.
Yeah, you have to come out of that presentation.
Okay. All right. Now, stop. Okay. All right. Now I'll be sharing the screen. And now. Well, I could have tried earlier. I'll be stuck with this one. Share. Is it visible?
Yeah.
Thank you. Well, yeah, now it's visible, Walsam. Thank you.
Now it's visible? Okay.
Yeah.
This is a gas lift system. This is a demonstrated clip. You can see that how the system works. Let me see if you have any problem viewing the clips. You with me?
We can see the slide, Walsam, but it's like not a video. So if you can just.
Not video?
Yeah, it's like only a slide showing up.
WhatsApp is only showing animations and videos. It's only giving the list of all the gas lift, plunger lift, the hydraulic lift.
Yeah, I can see that. I can see that. Okay. Let me go back. And then let me start with this clip and then see if I can share the screen. How can I share the screen?
You can Iqbal just quit from this slide, and you can go back again to the, you can watch the video. You can go directly to your screen again and watch the video. So if you want to go back, you just quit from this slide, the one we are.
I'll quote for the slide now. All right.
Yeah.
And now you screen sharing, new share.
You have to exit it, I think. Okay.
Yeah.
Is it running now?
Yeah.
Now
it's coming up.
Yeah, thank you. Thank you.
There you are.
Okay, then let's go back to the next one. Okay, now we're talking about plunger lift. Is it visible?
Yeah, it's coming up.
Let's go to the other one. Hydraulic lift. Now let's go to ECP. Now let's go to the next one, which is your ESPs. Not last, but not the least. In our words, actually, they call it donkey pump, some will call it rod pump, some will call it, beam pump, different names. This is the most old technology used in the industry. Okay, that concludes my presentation now. Now we can come to, okay, how can I come to? Now let me go back to full screen. Anyway, I think I'm getting a little issue now.
If once you can just pull out the presentation you want on the screen. So you would like to open the previous slides.
All right, okay, let me go back to the.
Yeah, you can just click on the your desktop screen. Yeah, from here you can just
Stop video. Okay. Now, all right. Here, okay. Questions, please. Any question? You got 10 minutes.
Thank you very much, Iqbal sir, for this wonderful presentation, and the forum is open for the questions. So if anybody has a question, you are allowed please to ask the question from Iqbal sir regarding the presentation, please.
But just want to add up, actually, in case you have a question, it's not answered in this session, you can always send it to Jawad. You can forward it to my email and I can reply accordingly.
Thank you. Also, I have personally one question that what is the maximum amount that ESP can handle in terms of gas, and what are the amount of sand ESP can handle? And secondly, if we want to lift from switch from one artificial lift system to another during the life of the reservoir, sometimes we face changes in the reservoir conditions. For example, if the GOR become very high in the later stage, so can we predict the GOR, in real time and future or something like that, and how we can manage the sand production, GOR with the ESP?
As I mentioned, actually, there are different applications. Actually, you have to select actually just to begin with, what kind of artificial lift system is desired for sand. The best is actually, rod lift system, and even gas lift is best. But sometimes actually, if you have already installed the system and you have set up an inventory and you invested millions and millions of dollars actually to setting up the system field wide, and it's not easy to change. So supposedly you have installed ESP and suddenly you go and increase some gas lift. Not standard gas lift is handled about maybe 40 to 50 SC per barrel, maybe 20. But sometimes actually it happens, because there's a gas separator. Gas separator can handle up to 200 SC per barrel, depending actually on the application. But no, gas going into the pump is not more than 10. So at least always less than 10. But nowadays, actually, there are pumps available now, which you don't need install intakes. They are multi-stage, high GR ESPs, and they can handle gas and solids and everything in one go. So this is a different technology, and they have been installed. We have tried in PDO, we tried in KOC. They work pretty successfully, yeah. But they are a different mode of ESP system. Now, your second question, how much maximum gas we can handle with the new and change system? We can go up to 90% free gas. You can't believe it? No, we have tried it.
That's great. It's great. Very great, sir. And one short question I was of that I have seen many cases and different fields which they faced corrosion problems. Specifically, I read about one field in Oman. They spent like approximately $500 million. In the later stages, they have faced corrosive material, corrosive problem in the ESPs. So how we can properly, plan for the corrosion, things like that, and solid materials.
Mostly, what happens actually, you have to decide actually just to begin with, what kind of system you need. It depends on the rate, the depth, and also the availability of the system and the inventory. Now, with the ESP, with the best system for a corrosion system is the gas lift actually, or sometimes even with the PCPs, you can handle it. PCP can handle sands very well. Yeah, you can go sand to higher extent. But nowadays, the ESP has been modified to the system, and I do have papers on it, and somebody interested, I can share it. They have tried with the 200 PTB sand, and they're trying to gas at as long as 500 SC per barrel, and they have tried water cut about 99%. They've done a lot of things, but everything costs. This is nothing free in the world.
Thank you, Iqbal, sir.
Any question, please? Anything else?
Okay, I want to add one thing. That Jawad, this presentation is not for 1 hour because the people will never understand anything in detail. This is a course which is 2 days, 3 days, and 5 days courses, based on the same thing, So yeah, in future when we present these courses somewhere, and at that time maybe we can, help the students more. But by rendering 1 hour course is just an introduction, what kind of lifts systems are available, not more than that, because if we go in detail of even one of that, it will take a whole day, So that's what I want to tell that.
I just want to add up with Sajjad Sahab actually, because my listing of the courses actually, first of all, actually for the common petroleum engineers or common oilmen, and maybe geoscientists, JME, petroleum engineers, maybe management system altogether to understand this. So this presentation is meant for those people. But now for going in details for the students, for the application engineers, for the petroleum engineers, the course goes from 2 to 5 days, where we go for designing the ESPs, we go for applications, we go for exercises altogether. So the course which I've delivered in Malaysia and Singapore, it was 5 days course. We go from right from scratch up to designing the ESPs and then monitoring it altogether. It's a very wide subject. Sorry to say that. Yeah.
Thank you, Aswad Sahab and Iqbal Sahab. We are really thankful for this presentation. And as you mentioned, it's just an introduction. And we would like to invite you in person. We will share the details with the students. And upcoming, months, we would like to invite you on campus, and we will properly arrange the, the session again on campus here. And definitely, we will go for training session, as you mentioned, for 5 days. So I think it will be wonderful, and the student will be able to understand the system, in a better way. And I'm very thankful for this offer.
But
And
I'll be waiting for it, and my priority will be always, just to sharing the knowledge, particularly with the students who can carry up the flag all the way for the system throughout their career. Yeah.
And we have also subjects in advanced production engineering for the PhD students, for the master's students, and for the undergraduate petroleum engineers. So definitely that will be very helpful for the student as well, and for all the people. So thank you very much, Iqbal Sahib and Asghar Sahib. And for the student, if they have any question, I will directly reach out to you, and we can further do brainstorming on the question as well.
Thank you very much.
Thank you. Thank you, everybody. Thank you. Thank you. Take care.
All right. Thank you very much. Appreciate for everybody coming and joining the session. And I hope everybody learned something. And this is an introduction. We will, if in case there's a group of students who are interested in a long course, like 1-2 days course, 3-5 days course, will make some special arrangement for that at a much cheaper rate and whatever possible.
Thank you, Asghar Sahib. Thank you very much, Asghar Sahib. Thank you very much. Thank you very much.
All right. Thank you very much.
Have a good day.
Wonderful day.
Thank you very much.
Bye. Bye. Thank you. Thank you. Thank you.